go over how we would do CI/CD with dbt before and after dbt 1.8. So there's an optimization that we can do now with this empty flag, which we'll cover in a few minutes. And this would allow us to run the CI/CD checks faster and reduce our spend when we're using something like Snowflake. So how did the CI/CD process work before? So what would happen is you would open a pull request and you start your CI/CD validations. You would run dbt, you do your linting checks with a tool like SQL Fluff, and then you do governance checks with dbt checkpoint. So a dbt checkpoint check would be something like making sure that the columns in a SQL file match the columns in a YAML file. Now, if one of these three things fails, you then start over. So now you go back over here, you make some modification, you push the code, and it begins the process again. The main issue here is that we're doing a lot of work in Snowflake. So we're doing the build, and we may find a spacing issue here. So this is not a very critical thing. It might be an indentation or capitalization or something like that. The same thing here. Maybe I forgot to add a YAML a column into my YAML file. So these are not very critical, but because I have them after the build, any error that I find requires I go back through this process and redo the dbt build. At some point, everything is good, it passes, and then your validations are good, you merge to production, you deploy. So this is how we've always done it, and we'll explain the why it has to be in that order. Okay, so let's look at the code of how this works. We start the CI/CD process, we install the dbt dependencies, we create an empty Snowflake database. And the idea behind this is so that we can make sure that every feature is tested in isolation. And what we will do is if we have a model A, B, C, and we only change model B, we're only going to test B and C. So we don't have to rerun A. That's the whole Slim CI process, which we'll talk about in a second. In order for that to work, we need the production manifest. So production manifest is going to be the manifest.json file that dbt generates, and we're going to compare that, the state of that in production with the current state in this branch. So if we find that file, we're going to do this step right here, where we're going to do a dbt build. This fail fast is just making sure that we don't run a bunch of dbt models if something failed. We're just going to fail fast, fix that model, and start over. Defer is where we're going to get the upstream models. So in my example, if I have model A, B, C, and I didn't change A is going to come from production. So I'm only going to build B and C. And this piece right here is telling us which directory holds the production manifest. In my case, I put in the logs directory. And this says, start running from the thing that changed and go downstream from that. So in my example, this would run B and C. And the reason we have to do it this way is for this next bit right here. So the way dbt checkpoint works is it's going to use two files. It's using a catalog JSON and a manifest JSON. The manifest JSON is it's being generated by dbt when it parses the project. It gets all the SQL, all the columns, all of that kind of stuff. The catalog JSON is generated by dbt when you do a dbt-docs-generate, and that pulls data from the database. So in my example, if I run model B and C, those two views or tables exist in Snowflake, and so the catalog JSON will have model B and model C, but it will not have model A because model A does not exist in this new database. This typically is not a problem except for one case. And the one case is if I add a new test to a model. How does this normally works? I can show it here with a dbt ls. So right now I haven't changed anything. And you see it doesn't find anything. So essentially saying this branch and production are identical. If I were to go into this YAML file, and let's say here I'm going to add a data test. If I were to change the SQL, then everything is fine because it's going to detect that I made that change. It's going to run that in the test database, this new database, and we don't have a problem. Also, if I change a description, it'll catch it. It's only in this case when I add a test. If I run this again, look what happens. So it just detected that there's a test, okay, the new test. So here's our problem. it doesn't exist in the database. So in my example, this would be model A. So let's say in my example, model A, I added a test, but it didn't actually change. So it runs the test against model A in production, it passes, it's fine. But model A is not in the database. Therefore, when dbt checkpoint goes to compare the columns of model A SQL file to model A's YAML file, it won't pass because it will say this model doesn't exist in the database. So to solve for this, what we did is we created this step right here. So what we're doing here is we have a special way of generating dbt docs using our library dbt-coves. So what we do here is we say, take the catalog JSON from production and merge it with the catalog JSON of this branch. So by doing that, now I have a full catalog JSON. I have model A that came from production plus B and C that came from this branch. Now that I have all of them, when I do that comparison, it'll pass. And then we can run the dbt governance checks. So this would be the linting that I mentioned and the dbt checkpoint. So that's what we're doing in this step, this pre-commit run. This last step is just to grant permissions for UAT or something like that in this final database. So right now I'm using a service account that would generate all of this stuff. But at the very end, I need to give people, humans, access to this database. So that's what we're doing.
So if this fails, if it fails in the governance checks right after the build, we're gonna have to go back and modify the code and then rebuild everything, leading to wasted builds, correct?
Exactly. We're going to go through this process that we were showing earlier. So let's say this linting check fails. We have to go make a change to the code, put it back, and that's going to redo the dbt build. So in my example, it's not too bad. I mean, I have model B and C that are running, so it's not too bad. But in the real world, you may have 10, 20 models or something like that that get impacted by a change. So this is before 1.8. Now 1.8 introduces a new flag called empty. So now what this allows us to do, we still do the dbt build, but this empty flag essentially will materialize all the models in this new database without actually performing any calculations. And then I can run my linting checks and my dbt checkpoint checks. Now, if these pass, sorry, if they fail, then I can go back, make the change, and go back through this process as many times as possible. And this will be a lot faster, and it's not going to be wasteful because I'm not doing any compute.
Yeah, because there's no data actually being populated inside of the views. It's just creating.
It's just empty views and tables. dbt is just
Views.
creating empty things. And it isn't until we pass everything, once we go through this cycle multiple times and then it passes, then we can go in and perform our dbt build. So now we've moved the expensive operation, the actual calculations, further downstream of the process. Now this could still fail, so there could still be a problem. However I generated maybe I have a dbt test that's failing, or unit test or something like that. That's fine. In this case, you would expect to have to run dbt again. So you would go back through here, it failed, and you go back, modify the code, and it'll go through these steps again. But the idea is you're avoiding running dbt itself and all the calculations until you passed these governance checks. So how does this look in code? So what you do now, similar to what you did before, we create the database, we get the production manifest, but here's that step now. So we're going to run the empty models right here. So this will run pretty fast. This one is when the manifest is found. This one is when there is no production manifest. In either case, even if I have to build model ABC, this will still be very fast because I'm not actually materializing anything. Then I'm going to still do the docs generate using dbt-coves because I still need to merge the production catalog JSON with the current catalog JSON in this. Then I could run my governance checks. And if everything passes, now I'm going to do the real dbt build. So this one doesn't have the empty.
Nice. So you'll be able to save some time and some money and some Snowflake credits by doing it this way.
Exactly.